of multiplicity, something that we saw last year in Algebra 2. And it comes down to what is our graph going to do? What type of behavior will we see when we sketch the graph at each of the roots or zeros of a polynomial? So to start, if we have a polynomial in standard form and then we break it down into factored form, should our polynomial contain a factor of x minus a to the power k, where k is any type of positive integer, we're going to say that the polynomial has a root at x equals a with a multiplicity of k. Think about it. Why is it a root or a zero? Because when we have x equal to a minus a becomes 0. It's one of the factors of our polynomial. When we ever multiply anything by 0, we certainly get 0. In other words, our polynomial will evaluate to 0. And the multiplicity of k says, well, if we have x minus a to the k power, what we really have is a bunch of individual factors, x minus a, x minus a, x minus a, k times. Now, depending on how many times this factor repeats itself, that determines what, again, we call the multiplicity. If we have something to the form just x minus a to the first power, that's called multiplicity of 1. And what our graph will do as it gets to the root, and we'll flip to this in the second page of these little quick notes, the graph just keeps going on its merry way. If it was increasing, it'll keep increasing as it goes through the root. If it was decreasing as it goes through the root, it will continue to increase. If it turns out that our value of k, the factor repeats itself an even number of times, such as x minus 6 to the x minus 6 squared, x minus 6 to the 4th power, x minus 8 to the 8th power. Anytime the factor repeats itself an even number of times, we're going to have U-turn behavior, a U-shape to our graph. When we touch the root, if we're increasing, we'll then start decreasing. If we were increasing, we'll decrease, we'll make a U-turn. If we were decreasing, when we hit this root, we'll turn around, we'll start to increase, a U-turn pattern. And finally, if k is odd, if this thing repeats itself, x minus a repeats itself an odd number of times with any odd number that's not equal to 1, so x minus a to the 3rd power, x minus a to the 9th power, so on and so forth, we'll have what I call traffic circle behavior. The graph will continue to either increase or decrease, but as it gets to the root, it kind of flattens out, as you do if you're going to try to go through a traffic circle and continue in the same direction. You're going at speed. You slow down as you enter the traffic circle and navigate through it, but when you come out the other side to continue in the same direction you were going, you pick up speed again. That's what I'll call traffic circle behavior with multiplicity. So down at the bottom of the note sheet that you had picked up originally, we showed you a whole bunch of different multiplicities. Red, blue, green, orange, and then dark purple. These different graphs that you see all show different multiplicity. Multiplicity of 1, plow through. In blue, U-turn behavior. In green, traffic circle behavior. Hey, x minus 6 to the 4th power, again, a U-turn type of behavior. X minus 8 to the 5th, you see a traffic circle type of pattern. And so a couple other quick things to note. Here are just some other examples that I gave you. I looked at one individual factor. This particular function has a bunch of multiplicities. It has 3 different roots, a root at x equals 5, a root at x equals negative 2, a root at x equals 3, a root over here at x equals negative 5. My apologies there. So 3 roots, x equal negative 5, x equal negative 2, x equals positive 3. The root at x equals negative 5 only repeats itself once. Look what we see, a multiplicity of 1. The graph is going down. It continues to go down. Our second factor, x plus 2 squared, well, that shows up 2 times, multiplicity of 0. And look what our graph does at the root. It turns and goes to the other direction. It makes a U-turn. And then finally, our third root was x minus 3 cubed. And what does it do? It does the traffic circle type of pattern. It was increasing, kind of slows down its rate of increase, and then picks up as it merges out through the other side of the traffic circle. Now, it's important again to note that whenever you see a U-turn, well, the default would be just to assume that it's a multiplicity of 2, but we could have, for that matter, this graph could have been, x plus 2 to the 4th, or at least that behavior that you see. So it leads to one other thing that I want to discuss very, very quickly. because this will be helpful to us. And that is the minimum degree of a polynomial as determined by multiplicity. So if we're staring at a graph, and we're just going to look at this bottom piece, we've already talked through multiplicity of 1, even multiplicity, and odd multiplicity, what type of behavior you have. But I've also started to show you the possible degrees that might be associated. So when you're looking at a graph that makes a U-turn, well, your default would be assume that that factor just repeats itself twice. But it could be, just depending on your polynomial, it repeats itself 4 times, 6 times, 8 times. In any case, what's this telling us? Well, a function with even multiplicity at its lowest will be a x minus a squared, where a is the root. It could be x minus a to the 4th, x minus a to the 6th, so on and so forth. But the lowest possible degree that could be associated with that multiplicity is 2. And similarly, whenever you see a traffic circle pattern, well, that factor could repeat itself 3, 5, 7, or 9 times, or any odd number greater than 1. By default, the lowest possible degree that you could possibly see is 3. So if you were looking at a function that had a pattern like this, I'm just going to draw one on a blank piece of paper very, very quickly, so just bear with me as I reach for one. Just use the back of an envelope very quickly. So I'm going to draw a function. Put -1, I'll put +1, I'll put +3 over here. And here's what I'm going to do. I'm going to draw a function. There's some end behavior. Goes up, turns around, goes like this. Hey, there's a U-turn. And here looks like I drew some traffic circle pattern at the end. Well, what do I know are some factors? Well, I know x plus 1 is a factor. I know that x minus 1 is a factor. I know that x minus 3 is a factor. I have a root at x equals -1. I have a root at x equals 1. I have a root at x equals 3. Now, if someone asks what's the minimum degree that this could be, well, here's how I do it. This is obviously multiplicity of 1. This must be x plus 1 to the first power. Here I'm seeing what? Even multiplicity. I'm seeing a U-turn pattern. This could be x minus 1 squared. Well, it could also be x minus 1 to the 4th, so on and so forth. I don't know all these points, but I know it's going to be something of this ilk. What's the lowest possible degree? We'll come back and talk about that in a second. But for this U-turn behavior, it'd be x minus 1 squared. And for my third, hey, here's some traffic circle behavior. Well, this could be x minus 3 cubed. It could be x minus 5 to the 9th for that matter. But if I say what's the minimum degree, well, when I look at this graph at face value, the minimum degree I'm going to see would be, I'll take my plow through that I already have. So I know this is a good factor. I'll look at my U-turn. Well, the lowest possible degree would be the x minus 1 squared. I'll go ahead and put that over here. And my traffic circle behavior. Again, it could be many different degrees here, all of them, 3, 5, 7, 9, so on and so forth. But the lowest possible degree I would have would be x minus 3 cubed. So when I look at this polynomial, here's the simplest version that I could build of it with all the roots. And what would I see from the multiplicity here? Add the individual degrees. 1 plus 2 plus 3. This would be a 6th degree polynomial. So again, I just want you to be comfortable with when you look at a graph, you can identify the multiplicity. You can also identify the minimum possible degree for a polynomial by knowing your basic rules. U-turn, traffic signal, plow through. So there's multiplicity wrapped up. It's going to be very, very helpful as we start drawing these complicated graphs in this unit.